Okay, so in this video we're going to briefly talk about trees. A tree is just a network that has no circuits. Okay, so remember, a network is a connected graph. So another way you could state this is a tree is a connected graph that has no circuits. One of these is a tree and the other one isn't. Okay, well, if you look, you can pause the video if you want to guess which one's a tree and then start it back up again. If you look at these, they're both connected networks, or connected graphs, so they're both networks. But this one here, I'll call it figure A. Figure A has a circuit. You could go from A to H to D to E to F to G to B to A. Okay. So that is not a tree. This one over here, however, because we took away this one edge from E to D, it's no longer a circuit. So this is still a connected graph, so it's a network, but it doesn't have any circuits. No, like right here is not, there's not a node. These are just two edges crossing each other. There's not a vertex there. So there's no circuit here. Remember, the vertices are labeled with letters, so there's not a node or a vertex here, so there's no circuit. So this is a tree, and I'm going to redraw it. Okay. You might see the word root in the reading. Well, what root means is you're going to redraw the graph so it sort of looks like a tree, like an actual tree. So I believe in the book they rewrote it, or in the PowerPoint, maybe in the book too. They drew it again with B being the root. But it turns out that you can pick any vertex that's in the graph and make that the root. But I think I'll use B too. I'm going to redraw it. I'm going to use blue pen. So I'm going to draw B down here. It's the root. And then I'm going to redraw the graph. Okay, so you have G, you have A, H, D, okay. Then you have F and E. And there's also a C in here. So if you look, I'll call this figure C. If you look at figure B and figure C, they're the exact same graph. Every edge that's in this graph is also in this graph. Notice we have an edge that goes from G to F. It's right here. H to D has an edge right here. A to B has an edge right here. So these two graphs are actually identical in their meaning. They have the same vertices and same edges. We just drew it so that we had a root and that it looked like a tree. I know you're going to probably say this doesn't look like a tree, but it looks more like a tree than the other graph. So I think I want to try to redraw it again, just to show you that you can pick any letter to be the root. So I'm going to pick G to be the root. This is going to be hard for me, so I'm going to pick G to be the root. Okay. Well, G goes to two different things. It goes to F and C. So you have to have two things coming off. This could be F. This could be C. F just has one other thing coming off of it, and that's E. So C C doesn't have anything coming off of it. Oh, well, G also, I misspoke. G also has a line going to B. I think I want to redraw it. So, because there's more coming off of B than there is off of C. So I could just put maybe going to C here, then to B here. And then B has a edge going to A. Then A has one going to H. And then H has one going to D. I think we have everything there now. Okay, so that would be the graph redrawn with G as the root. So everything's the same. All the information's the same. All the edges that are in that graph are also in this graph. Okay. So that's what a tree is. It's just a network that has no circuits.